In this video we'll talk about programming functions. Functions, or in some languages known as procedures or routines, are blocks of code with a specific function or purpose. This code is grouped together in a nice little package and can be called or used from different parts of the program as required. So they're nice little blocks that we can use at any time. There's a few different advantages of using functions. Well, firstly, it makes the code a lot easier to read by hiding all the complex implementation details inside a function, allowing a programmer to quickly get a good overview of what the code's doing from a very high level. They can look at what all the functions are and see how they fit together. Also, functions promote what we call code reuse, which really improves reliability. So rather than coding something from scratch every time you need to perform a particular task, you can call a function that you've designed well and thoroughly tested and know should work well. You're reusing that block of code. Well, to use a function, we actually need to call it. We'll look at a few examples of this in a moment. When we call a function, we can supply data to the function. This is called passing parameters to a function. A function may have 0 or more parameters. We might not pass anything to it. We might pass a whole bunch of different arguments to it. A function may also pass some data back, like if it performs some sort of computation and wants to supply the result back to whatever called it. This is called the return value. Now we don't need to have a return value, but if we do, normally we just have one return value. Now functions are written outside of your loop function, so they're not inside the loop function. We call them from inside the loop function. And we normally write them underneath and use something called a function prototype, which we'll look at later, to show how the loop function should actually call them, how they actually interface. So here's the general form of what a function should look like. It has a return type. Now, we've talked about different types like integers and longs and characters. So if we have a return value, that's where we specify it. Now, if we don't have a return value, if our function is not supplying any information back to the rest of our code, we write void here to indicate there's no return value. We then give the function a name, and we generally pick a name that has something to do with the purpose of the function. That makes it easier without having to delve through all the comments you've written on functions to work out what it actually does. Now then we can have our parameters or our arguments that we supply to the function, and each of these has a type, like an integer or a long or a character, and a name. So a name will be, once again, something that relates to the purpose of this parameter. If we don't use any arguments, we can write void in here. Now inside the function, we'll have a whole series of statements, one after the other, and if we're returning something, we write the command return and then the variable or the value that we're returning. For example, return 1 or return counter value. Let's go through a basic example first. We'll go and write a function that will flash an LED on and off a prescribed number of times. So let's start by writing the actual function. So we'll call our function flash LED num times, and we don't have a return value because everything's done inside the function. So our function starts with a void. We put a void whenever there's no return value present. So we'll give it a name. So that's a pretty obvious name. What it does, it flashes LED a number of times. We need to give it a parameter. This will be the number of times we actually want to flash the LED. Now for this, we may as well just use an integer, and we'll give it some sort of useful name like flash times. Now we actually need to write the inside of the function. We need to make it do something. Easiest way to do this would be to write a simple for loop. So we'll create an integer here that we can use to count. We'll call it I just for convention. While it's less than flash times, we want to run this and we want to increment I. Okay, so this will run for the prescribed number of times depending on what we give flash times. If we supply a value to the function flash times equals 5, this will run 5 times. Now we'll set the LED on and delay for a bit, set the LED off and delay for a bit, and then we'll do that for however many times we need. So digital write, we'll call our LED LED1, So we'll turn it on, delay for 200 milliseconds or so. That'll be enough to be able to see it. And we'll turn it off again. And we'll delay for the same time period we had before. Okay, now a few other things we need to do. Firstly, we need to define LED1. So int LED1 equals 6, because we'll be on pin 6. Now whenever we create a new function, we need to create a function prototype. This is basically a header to show what the function's meant to look like and how we interface to it. Our function prototype is basically this line of code that we take and put up the top, but instead of having our open brace there like we used to start a function, we ended in a semicolon. Now we need to write the rest of our code to actually call this function and make it work. So of course we have our setup function, and we need to set that particular LED pin as an output. So we use our good old pin mode. As an output, and we use our loop function, and we call this. So flash LED num times, and then we specify the parameter. So let's flash the LED 5 times, and so that we can actually see it working, because this will loop around and just call the thing again, we'll put a delay in here of 3 seconds. We'll hit compile and make it run. Now we're going to go through a slightly more advanced example. In this example, we'll use both parameters that we pass to our function and also return values that the function returns back to us. The function that we're going to create is a factorial calculator. Now, just brushing up in your maths, factorials are numbers that we calculate by multiplying or calculating the product of all the previous numbers. So if we want 5 factorial, we say 5 times 4 times 3 times 2 times 1, which happens to be 120. So let's go and create this factorial calculator. We'll start off by creating the actual function. So because factorials can get rather large very quickly, rather than just using an integer like we have been in the past as our return value, we're actually going to use a long, because a long uses twice as many bits to store the number, and so it can store larger numbers than an integer. So we'll give it a name, factorial calc, and we need to supply to it the order of the factorial, which factorial that we want to actually calculate. Now this number is typically going to be a whole lot smaller, and so we give it a sensible name like factorial order. We then, because we're doing some computation in here, we need to create a temporary variable that we'll be using, and this will be the variable that will return at the end. Now that needs to be the same type as our return value, which is a long, and we'll give that an initial value of 1. Now at the very end we're going to be returning this. So we say return count value. When we get to this point in the code, it actually gives that count value back to the program where it called it, and it can assign it to something. Now let's actually create our loop to calculate the factorial. The easiest way to do this, probably use a for loop. We'll create a temporary variable, we'll call it I. This will be our count variable. So if that's less than or equal to the factorial order that we're passing in, we want to run this, and we say I++ because we increment, and there we go. Final thing we need to do is actually compute the count value. So we say count value is equal to count value times I, because it's the sum of all the numbers, the less than factorial order. Okay, so we've created our function. Once again, right at the very top, we need to create a function prototype. So we put that there and put a semicolon at the end of it. So our function prototype's created. We might do something a little bit fancy this time and create a loop, so it will loop through and show us all the different factorials and calculate them one after another. So we'll create a variable to allow us to do this. So we'll call it fact counter. Now, so that we can get some feedback from our microcontroller, what we'll do is we'll set up the serial port so it can send us the factorial result that it's calculating. And we'll initialize our fact counter value to start at 0, which will give us the first factorial. Now, by convention, the factorial of 0 is 1, which has already been factored into our factorial calculator calculation below. Now, let's have our loop function. And what we'll do here is we'll create a variable that we can store our factorial result in. Now, that's a long, remember. So let's calculate that result. So we say fact result is equal to, so we're assigning the return value of our factorial calculator to fact result. And what we're using here is we're passing fact counter to it. Now we need to print these values out and send them back to the computer. So we say serial.print. First we'll print out the order of the factorial, or whatever's in fact counter. Next we'll print out some sort of division that we can divide these up nicely. And finally we'll print out the factorial value. And we'll say print line, so each one will print on the next line after it's finished. And of course we want this to count through several different factorial counters, so we'll say fact counter plus plus, which is the same as saying fact counter equals fact counter plus 1. Okay, we'll compress that a bit more so we can see it all. And we don't want this to happen too quickly that we can't see the result, so let's put a delay in here. So delay for 1000 milliseconds or 1 second between each calculation. And once that's uploaded, we can open our serial monitor and see the results we're getting. So factorial of 0 is 1, factorial of 1 is 1, factorial of 2 is 2, 3 is 6, 4 is 24, 5 is 120, and so on. You notice one interesting thing. When we get from 12 to 13, this is actually the incorrect factorial, 19.32.053.504. And the reason it's the incorrect factorial there, and you see there's some unusual ones coming out even in the negatives after that, is we're creating a number that's bigger than what our long variable can actually hold. Because it's bigger than what it can hold, it actually wraps over and becomes a negative number. These are signed long integer numbers. And at some point it will become 0, and when we multiply something by 0, it will be 0, and hence we get 0 numbers afterwards.